Hey, I'm feeling a little good about myself since I just solved the other problem, so fuck it, let's do this problem as well. I did kind of get a hint on how I can work with this, so it's not like I'm gonna be completely clueless, so keep that in mind. Reading the problem, we need to find the kth largest integer in a stream of values, including the duplicates. So in this case, 3 would also be counted in here. And initialize the object given an integer. Okay, so we do need to use a min-heap so we can keep track of all the values, with the minimum being the one at the very top. And the reason we want to do this is because we want to use a little trick. Since we only care about the kth largest element in the stream, we only need to keep track of the top k elements. Everything less than that doesn't really matter, does it? So whenever we're adding something, we have to make sure that it fits within the k length and stuff. And like, if it exceeds it, we pop the minimum because that doesn't really matter anymore. It's going to be out of the length. And on first initialization, we also need to make sure that it is a k number of elements. That is the trick. I tried doing a solution that is so scuffed where I try to add it back, but that just overcomplicates it. We don't need to do that. We don't even need a max heap, because if we have a min heap, the value at the very top, the very first index, that is what we need to return. We don't even need to pop it, really. We can just keep it there. So let's do just that. Let's initialize the min heap, and let's initialize k. So for min heap, it's going to make it nums and k. And now we heapify this. Heapify min heap. And now we try to get rid of this. While len min heap is greater than k, right? Because we want it to be k. Then we just pop it. Heap pop. There you go. Oh, and my mistake. I need to add that self, just to make sure. Now, whenever we do add something, so heap q dot heap push self dot heap val now while len self dot heap is greater than k. Just do this. I just copy that code, and then we return heap q self dot min heap 0. So we're pushing a new value, and then if it's greater, we pop it. Kind of like what we're doing here. This is just to make sure that everything is within the kth largest element, and we just return the very beginning of the index. I think that should be it. Let's try and see if this actually works. Okay, so that's where it's wrong. Oh, okay, now I see it. So we have to define this as self.k because it's not there. There you go. Nice. And I think this should work. Perfect. So this has a time. Okay, so initializing the heap has a time complexity of O of n and a space complexity of O of n as well. And every time we're popping, it's O of log n, basically. So, or log of k, if you will. Initialization O of n has a time complexity of O of n. Adding has a time complexity of O of log k, basically, where k is the length of, the k is like the, k refers to the, like the kth largest element. Dude, I'm tripping over my words, but you get what I'm saying. And that's it. You don't have to do this n times. Yeah, it's just O of and like the space complexity should be O of k, honestly, because yeah, it's O of n on initialization, but we're popping it and always maintaining it to be log of k. I mean, to be k. So let me just double check that. M log k. What is M, bro? Times add is called. Oh yeah, because it's called this many times, right? Okay. But basically the add function is log of k. Yes, that's correct. And it is OK space. Okay, there you go. Nice. Yes. All right, that's good. Honestly, really good. That was very straightforward. And we wrapped this up quite fast, actually. I don't really have anything else to add. Yeah, nice.